Last unit of Algebra 2. It is an important unit because it deals with statistics and data analysis. We are going to look at 11.1, statistical questions and variables, 11.2, statistical studies and sampling methods, 11.3, data distributions, and 11.4, normal distributions. An important thing for 11.1, which we're going to do all in one day today, is to be able to use the vocabulary that deals with statistical questions and variables. So you'll want to get your notebook out, a lot of vocabulary in this, and then you can write some examples of each of the vocabulary definitions. Here's something that might happen in statistics. So you collect some data. A state questions some of its high schools about the price they were charging for prom tickets. The results are summarized in this histogram. So we can see on the x-axis we have the individual ticket costs, and these are the number of schools that had that cost for prom tickets. You might think about what are some questions that could be answered using this data. You might be interested in the average overall of these schools, the overall average cost. You might think about why some schools might be more than others. Anyway, you could look at different, or where these schools were located, you could find some other information out about. Anastasia is surprised that the median cost of a prom ticket is not higher, given that her school is charging $60 per ticket. What are some possible reasons for the data not conforming to her expectations? And who knows what was going on at these proms and what they offered. Could be specific hours that the prom was held, the location, things like that. So statistics can be used for a lot of different purposes. We want to see what kind of questions about quantities and relationships among those quantities can be answered with statistics. Here's a list in alphabetical order of the vocabulary that we're going to cover in just today. So by the end, you want to make sure you have all of these answered. We're going to go through them as we go along. So here's our first example. We have two questions. In what month is your birthday? And the second question is, what month has the most birthdays of students at your school? Now take a look at these questions. It's important that you can analyze and think about what these questions are asking and what kind of answers you would get from those. So what's the difference between these questions? If you look at question 1, there's only one answer. When you ask somebody what month is your birthday, there's one answer that's very, very specific. Question 2, this is a little more general. It can be answered by collecting many pieces of information and summarizing them. So question 2 is considered a statistical question. When you're going to collect data, you want to be able to ask a question that can be answered by collecting many pieces of information, and you want to be able to summarize the data. You could summarize it with just a table. You could summarize it with a graph, a histogram, whatever you're choosing to summarize the data. So question 1 is helpful for collecting the data, and question 2 is more for collecting the data for question 2, sorry. So question 1, being very specific, will help you collect the data for question 2. Little study tip down here. The answers to statistical questions can be summarized in different types of displays, such as bar graphs, line graphs, scatter plots, and frequency charts. Probably remember some of those from your earlier math classes. So here is a graph that displays some information, and we want to know if this could possibly answer a statistical question. And I'll read this to you since some of it's off the screen. Um, this first one, distance traveled to school and the student's age. So this graph does represent some students' answers to the question, how far did you travel to get to school? So this is a statistical question because it's answered by gathering and summarizing various students' answers. And notice the answers are all different. This other one, however, we have a distance and the time, travel time at 20 miles per hour average speed. So this graph represents answers to the question, how long does it take to travel X miles at 20 miles per hour? This is a question that has a predetermined answer. I can just figure it out, right? The answers, the answer does vary, but it's predictable based on X, right? Depending upon how the distance that you traveled, you can always figure out the time because it's just a straight out answer. It's not a statistical question. It doesn't vary at all. And you can look at the graph and tell that. This is just a little side note here. Your English teachers will like this one. So the word data or data, some people say data, some people say data, is a plural noun. So use it with plural verbs like these data are or the data indicate. However, set and value are singular. So use singular verbs for them like this data set or data set is or the data value is. And for this is my little help over here. When I can't decide which verb to use, I substitute the word they for the word data to figure out which verb to use. But I do have to think about it oftentimes, and this is really picky. A lot of times nowadays we just say data as singular and plural, but technically the datum is the singular of data or data, datum. And this comes from the Latin roots of the word. Let's look at this thing. So this is a sketch by Escher. You might be familiar with him. Which is the most popular visual arts form? Photography, painting, sculpting, or drawing? Is that a statistical question? Yes, it is because it can be answered by collecting many pieces of information or data and summarizing the data. So as long as you can collect, it's not all one answer, and you can get a variety of answers, and then you can summarize it, it is a statistical question. Now, if I asked how many lithographs were created by the artist M.C. Escher, and this is one of them over here, which look at it closely because they're kind of interesting. This was not a statistical question because there's just one answer to this question. Now we're going to talk about statistical variables. What types of statistical variables is represented by the following question and the corresponding chart? So somebody asked, what is your favorite summer Olympic sport? And they've got these answers and they put the percents down here of the people that they asked. So a statistical variable is a quantity or quality. Remember those two, quantity and quality, that can be measured or counted, for which data are expected to differ from one observation to another. The two main types are categorical and quantitative. Categorical and quantitative. Quantitative variable is a variable that can be measured or counted. So think of quantity. Example, the average price of a shirt in every store in the Mall of America. That's a quantitative variable. Categorical, or sometimes called qualitative variable, is a variable that is descriptive with regards to an observation but cannot be measured. For example, the color of the shirt that is preferred. Let's look at this example. What type of statistical variable is represented by the following question and corresponding graph? So the question was, what is the typical number of apps a teenager has on a smartphone? And somebody asked this question, collected some data, and analyzed it here. Notice that this is quantitative. This is a quantitative variable because the answers are a number, the number of apps. So in the context of the data that's compared, added, subtracted, or otherwise operated on, this represents a second type of statistical variable, a quantitative variable. The number of apps on a phone is a quantitative variable because the values are numbers that you could meaningfully count, add, and subtract, and so on. And this is just a little side note here. Some variables, such as month or semester grade, can be categorical or quantitative depending upon the context. So you have to ask yourself a lot of questions. Try this one. What is the statistical variable represented by each of the following questions? Is it categorical or quantitative? So if I said, what breed of dog is most likely to be adopted from an animal shelter, what do you think? If you said categorical, this is correct because a breed would have not a number. You couldn't count a breed. Breed would have a categorical answer. What is the average number of students per activity participating in after-school activities at Jefferson High School? What do you think? Did you say quantitative? Yes, because it's a number. You're looking at the average number quantity of students. Try this one. So there's fruit colors here and the number of pieces of fruit over here. Is this quantitative or categorical? They're grouped by color. That right off the bat tells you that's a category. There is a number of fruit, but the variables themselves, think of the X variables, are categories. So you are counting a number of fruits, the number of fruit that are certain colors, but the categories themselves, right, are the X-axis. That's what you're measuring. That's what you're asking about. Distinguishing between populations and samples. So here's two more new words. Population, samples. These are a little different in the general way we use these terms. When we're talking about statistics, it's a little different. So population, you want to write this down. You can always stop the video if you need to. It's the set of all members of a group that you want to know something about. All members of a group. So you pick your group, and then if you choose all the members and ask them that question, that's the population. So in this one, a school newspaper randomly selected 30 students from each grade level to participate in a survey to determine the opinions of students at the school. What is the relationship between the sophomores surveyed, all the students at the school surveyed, all the students surveyed, and all the students at the school? So we're going to look at this. So the group of all the students at the school is the population. All the students is the population. So population is everybody. A sample is a subset. So if I just chose a small group, like a random group, random 30 from each grade level, that would be a sample. And this is practical, correct? So if sometimes you don't have the time or the ability to ask everybody in the population a question or survey every household or whatever you're looking at. So this is just a practical thing that we take a sample and we analyze that sample data. The group of all the students who were surveyed is a sample of the students at the school, as is the group of sophomores who were surveyed. So So I've got two different samples. I've got the surveyed students, and then I've got just the sophomores that were surveyed. So those are two sample sets here. And just so a side note, in statistics, a population does not have to be made of people. The population is whatever group that is under study. It could be a group of corporations, a group of body of waters, a group of cars, something like that. Here's another example for us to look at. A polling organization randomly chooses eligible voters in the state of Illinois to ask who they would vote for in an upcoming election for governor to determine who will win the election. So you've heard of polling stations before, or polling organizations, phone calls, or however they do it. What are the sample and the population in this scenario? So the population would be all, think of all when you see population, all eligible voters in the state of Illinois. The sample is the people the polling organization asked about their voting plans. So this is always true that the sample will be a subset of the population. So look at this one. You try this one. A city worker collects 5 vials of water from each of 10 randomly selected locations all over the city to test the levels of bacteria in the city water supply. What is the sample in this experiment? The sample is the 50 vials of water that were collected. What is the population? The city's entire water supply. Now we're going to go one more step. When we have a piece of data, no, I'm not sure if I used that correctly. When we have some, we want to know, is it technically a statistic or a parameter? Now this is more statistic vocabulary. So a parameter is a measure that describes a population. A statistic is a measure that describes sample of the population. So population, everybody, parameter, everybody. PP, population parameter. Sample, statistic, subset. Sample, statistic is a subset. So if I have a high school that has 3 lunch periods, and in a randomly selected lunch period, 24% of the students brought their lunch from home, and I want to know, is this quantity a statistic or a parameter? So the entire high school population, that would be your parameter, however many students you have in your school, 2,800 or so in Edina, I believe. And then the sample is, in this case, the high school students that were having lunch. They also randomly selected a smaller group of that, right? So that's a sample to also. 24% is a statistic since it measured the sample of the population. Statistic, sample. The high school students that were having lunch. So it's just a small portion of it, not everybody. At the end of the first year of its business, a movie theater collected data on how well its concession stand operated that year. The theater used its total yearly concession sales. Okay, those kind of, I pay attention to words like total, and number of tickets sold to calculate the mean amount spent at concessions by a moviegoer, and they found it to be $8.14. Is this a statistic, meaning it goes with a sample, or a parameter, which would go with the entire population? If you said it's a parameter, you are correct, because it's the entire population of every moviegoer for that year and how much money they spent on average. Here's a general statement. Categorical data are often summarized using proportions. Remember the category? And then quantitative data are often summarized using a mean or median. So think about that. Proportions, you might say, 84% of the people preferred horror movies over rom-coms. Quantitative data like we have here, the average amount spent was, here's something for you to look at. Is the data summary a parameter or statistics? 53.2% of a district's eligible voters for the sitting U.S. House representative voted for the sitting U.S. House representatives. What do you think? It's a parameter because it relates to the entire population of eligible voters. The median age of a car in a 20 randomly selected spaces in the school parking lot is 7 years. So think of that word randomly selected. That would make me think it was a sample, exactly. And it's 20 cars out of the entire population. So it would be a statistic. Here's another one. A snack company produces bags of almonds so that each bag contains about the same number of almonds. The bags are filled with an average of 27 almonds. Carter gave each of his friends a bag of almonds for a snack after school. Their 5 bags contained an average of 31 almonds. What is the parameter and the statistic? So think about parameter, population. Statistic, sample. The parameter is the 27 almonds per bag. So that's my calculation, the 27 almonds per bag. It's an average. The statistic is the 31 almonds per bag because that's the average of my sample. This is the same thing, again, just with pistachios. So if you're a pistachio lover, you might want to read this one. This is a very good summary of this section. So you want to look closely at the vocabulary and make sure you understand each of those vocabulary words. And it does take practice seeing it over and over. So your Math Excel has several questions about a parameter, several questions about population versus sample, and parameter versus statistics. So you want to go through that a little bit. All right, I hope this is actually very practical, and if you find you like this section, you may want to take AP Stats down the road, because this is something that you'll go into a lot deeper in AP Stats.